Hi everyone, and welcome to The Sleepy Scientist. I'm really happy you're here. Tonight, we're going to go on a calm and quiet trip to learn something amazing. So get comfy, take a deep breath, and let's enjoy this peaceful science story together. Before we start, tell me in the comments, where are you watching from and what time is it for you right now? If you like relaxing science videos, don't forget to tap the like button. Now let's begin. Far beyond the warmth of Earth, where the sun is no longer a fire in the sky, but a pale shimmer through frozen blackness, Jupiter waits in silence. It is not a solid world like ours. It has no mountains to stand on, no oceans to wade through. Instead, it is made of gases that flow and swirl endlessly. Its heart is hidden beneath miles of stormy clouds, wrapped in cold winds and colours that drift like painted dreams. Yet this planet, this massive spinning colossus, breathes in its own way. The storms on Jupiter do not pass like weather on Earth. They live for centuries. Some are older than any living creature we know. They turn and turn wide as continents, slow as thoughts before sleep. The great red spot, the most famous of all, is like a single endless inhale of breath, held in place by invisible forces that we are only just beginning to understand. To look at Jupiter is to watch time move differently. Its stripes of brown, beige, white, and rust aren't painted on. They are rivers of wind, each one going a different way. They wrap around the planet like giant flowing dreams. Some go east, some go west. And where they meet, they fight. The winds clash and rise, twist and spiral until storms are born. But these are not like our storms. There is no rain you could catch in your hand. No thunder you could hear with ears alone. These storms are made of gases and lightning the size of cities, and their colours change like the breath of sleeping giants. If you floated close, your body would never touch a surface. You would fall into Jupiter like a feather in a bottomless sky. The upper clouds are made of ammonia ice, cold and light like frozen mist. Below that are clouds of water, deeper and heavier. Farther still, the pressure grows and the gas becomes liquid. Even deeper, it becomes metallic. Hydrogen, the lightest thing in the universe, becomes something heavy and strange under Jupiter's weight. It flows like a sea, but carries electricity like metal. And in this secret ocean, invisible lightning is born. No eye has seen it. No ear has heard it. But we know it's there, because Jupiter's storms send out whispers, radio waves, magnetic storm sighs, that ripple across space. Scientists send machines to listen. They orbit the planet like moths around a lantern, catching signals and photographs and fragments of wind. The Juno spacecraft, one of the latest travellers, dances close and pulls back over and over again, sketching the giant with invisible pencils of data. Juno found things we did not expect. Beneath the clouds, Jupiter's storms extend deep into its belly, hundreds of miles below the tops we see. It is as if the whole planet is a single living breath, rising and falling slowly, endlessly. These storms do not move with chaos. They have rhythm like music we cannot hear. There are places on Jupiter where storms line up into neat patterns, rows of ovals, like pearls in the sky. Scientists call them strings of storms. No one fully understands why they form or how they stay. They are like dreams that repeat each night, without reason, without end. They twist and roll and shift, but they do not disappear. Perhaps Jupiter remembers them. Perhaps the planet has a kind of memory, stored in its winds. And what of the colours? Jupiter's storms change hues with time. Some fade from red to pale pink, others darken into browns and greys. These are not just for beauty. They are chemistry in motion. Sunlight breaks apart molecules in the air. Particles from space crash into Jupiter's skin. New gases rise from below. Together they paint the storms like an artist layering brushstrokes. But this artist is the planet itself. Each swirl, each ribbon of cloud is Jupiter dreaming its own colour. There are smaller storms too, spinning in the shadows of giants. Some of them merge and grow, like thoughts collecting into a story. Others vanish suddenly, like dreams forgotten on waking. Once, scientists saw a white spot grow on Jupiter's surface. It was new, it was small, and then it joined with another, became stronger, and turned red. The planet had made a new mark on its face, a new breath in its long sleep. The deeper we look, the more alive Jupiter seems. Storms are not dead winds. They have shape, movement, memory. They rise, fall, collide, and last. They are poems written in clouds. Every one of them is different. Every one of them tells a secret that only the planet knows. Jupiter does not have seasons like Earth, but it changes. Slowly, with a patience we can hardly imagine, it shifts. Its poles have storms like cyclones spiralling in rings. These patterns are new to us, discovered only when we dared to get close. The cyclones move as if they are part of a silent choreography, always turning, never touching, always dancing. And somewhere in the core of Jupiter, hidden far beneath the clouds, is a place no one has seen. A place where pressure is so great even atoms are squeezed into something strange. This is where Jupiter's heartbeat lives, if it has one. This is where the storms begin, maybe. Or maybe they rise from somewhere else, from layers we do not yet understand. But above all, the storms breathe. Not like lungs, but like a tide of gases moving through a living sky. This breathing has gone on for billions of years. Long before Earth had forests, long before animals looked up at stars, Jupiter was already there, turning, spinning, dreaming in silence. Let's drift deeper into Jupiter now, not through space, but through feeling. Picture the inside of a dream that never ends. That's what Jupiter's storms are like. Not just weather, but memories caught in motion. The planet is old, older than the Earth, older than most of what we see in the sky, and its storms may hold echoes from when the solar system was new. These swirling patterns of gas and light are like ancient lullabies, still being sung in the language of wind. Each one is shaped by invisible forces: rotation, magnetism, pressure, heat. These forces tug at the clouds like strings on a puppet, guiding them into forms no artist could have imagined. The planet spins faster than any other in our solar system. A day on Jupiter lasts just 10 Earth hours. That means the clouds are being whipped around at hundreds of miles per hour, stretched and bent and curled by the speed of that spin. This is why Jupiter's storms look like they do. Long, banded stripes circling its middle, giant ovals rolling slowly in wide loops. The faster it turns, the more powerful the winds become. It's like the whole planet is spinning itself into a constant state of dreaming, never quite waking up. And there is music here. Not music you can hear, but patterns that repeat in rhythm. Scientists call these Rossby waves, deep, slow-moving undulations that shape the weather on Jupiter, like ocean currents shape the seas on Earth. These waves help create stability in chaos. They hold the storms in place. They keep the dream from unraveling. On Earth, we have similar waves, but they're small. On Jupiter, they span thousands of kilometers. They move with the quiet dignity of old things, things that have lasted longer than memory. Deeper inside the planet, strange things happen. The pressure grows so great that gases are crushed into liquids, and then into something even more bizarre: metallic hydrogen. It flows like a river, but it conducts electricity like a wire. This is one of the secrets behind Jupiter's enormous magnetic field, the strongest of any planet. This magnetic field traps particles from the sun and funnels them toward the poles, creating glowing auroras, northern and southern lights far more powerful than the ones on Earth. These auroras dance in the sky like curtains of plasma, moving to a tune we cannot hear. They are the planet's way of speaking through light. And still, the storms turn. Some of them spin clockwise, others counterclockwise. They rise and fall, pulling warm gases up from the deep and sending cool ones down. This movement creates patterns we can't fully explain. Sometimes storms appear in pairs, sometimes they disappear without warning. But always the planet goes on turning, like a song that never ends. The great red spot, once wide enough to swallow 3 Earths, is shrinking. Slowly, gradually. Some wonder if it is dying, others think it's changing. Perhaps it's just part of Jupiter's way, an old storm making room for a new dream. We watch this from far away through telescopes and space probes, but we feel it too. There's something deeply human in watching storms that never touch ground. Something quieting, something humbling. It reminds us that not all things are made to be touched. Some are only made to be witnessed. Jupiter's atmosphere holds secrets in its layers. Stripes of ammonia, clouds of water, deeper bands of hydrogen and helium. These layers are like the pages of a book written in wind. Each tells a piece of the story. Some pages shimmer with ice, some glow with heat, some are too deep for light to ever reach. Scientists study these layers through sound, not the kind our ears hear, but waves that bounce and echo through the planet. These echoes help us understand what's hidden below the clouds. We call this helioseismology when done with the sun. With Jupiter, it's still a mystery. but the idea is beautiful. Listening to a planet by feeling how it vibrates, like putting your ear to the chest of a giant and hearing the thunder of its dreaming heart. The moons of Jupiter also play a role in its storms. Each moon, large or small, tugs on the planet with gravity. These tugs can stir the atmosphere, like a spoon in a vast cup of clouds. Io, the volcanic moon, sends material into space, some of which falls into Jupiter's atmosphere, changing its chemistry. Europa, covered in ice, reflects sunlight back onto the planet. Ganymede and Callisto, massive in their own right, orbit like sentinels. Each one leaves a mark, subtle but lasting. Jupiter is not alone in its dreaming. It dreams alongside its moons, and their rhythms shape each other in ways we are only starting to grasp. Even more mysterious is how the magnetic field influences the storms. It may guide them, shape them, or even protect them. There are places near the poles where the magnetic field and the storm seem to move in harmony, as if connected by an invisible hand. Some scientists think this is where weather becomes something more than weather. It becomes a pattern of energy, wrapped around the planet like a second skin. Jupiter's beauty lies not just in what we see, but in how little we know. Every answer leads to another question. Why do storms last so long? Why do they form in certain places? What is hidden beneath the deepest clouds? These questions linger, floating like mist in the space between certainty and wonder. But perhaps that's what makes Jupiter feel so alive, not just its size or its storms, but its ability to hold mystery. It does not rush to explain itself. It waits, it turns, it dreams. And in those dreams are colours that shift with time, shapes that rise and fall, heat that moves in silent loops, a planet where storms remember their beginnings and clouds fold like pages in a never-ending book. You can almost feel the softness of those clouds, the warmth rising from below, the slow pull of gravity that never lets go. It is like being held in a cradle of air and time. Jupiter is not just a planet. It is a place where science becomes poetry, where storms become lullabies, and where dreams, once started, do not end. Now imagine you are drifting slowly, deeper still, through the thick folds of Jupiter's air, where the light fades and the pressure grows. The storms above are far behind you now, like fading music. Below, the world becomes stranger with each passing mile. The air is no longer air, it is something heavier, something almost like water, but not quite. It pushes gently against you from every direction, like the warm, slow movement of breath in sleep. This is where Jupiter's dreams live, not in the clouds, but in the layers beneath, in the places we cannot see, where chemistry and memory begin to blur. Jupiter is not made to be seen in full. Its surface is a secret, and maybe that's the point. What we call surface is not a place, but a transition. Gas becoming liquid, liquid becoming something more. There is no edge to stand on, no ground to press your feet into, just layers that drift into one another, each one older and heavier than the last. As you move down, the temperature rises. It gets hotter than any furnace on Earth. The pressure climbs to levels no human could survive. Yet still the storms churn. Still the planet spins. Still the hydrogen flows like silver lightning through a sea of heat. In these deep layers, strange things may happen. The planet's inner core might be made of rock and ice and metal, or it might be something Sophia, something melted by time and pressure into a glowing soup of ancient material. No one knows for sure, but whatever it is, this core has shaped every storm above it. It has guided every wave of wind, every ring of cloud. The energy that feeds Jupiter's atmosphere doesn't just come from the sun, it comes from within. Jupiter is still releasing heat from its birth, a slow exhale that has lasted for billions of years. It warms the clouds, stirs the winds, and keeps the giant planet breathing. Think of how long this has gone on. Before the Earth cooled, before the moon formed, before the sun even settled into its golden light, Jupiter was already spinning, already dreaming. It was the firstborn of our solar system, the great protector, the massive anchor that shaped the paths of every other planet. Without Jupiter, the Earth might not have survived. Its gravity pulled in comets and debris, shielding the inner worlds from chaos. In that way, Jupiter has always watched over us, even from afar. And so we return to its storms, not just as weather, but as memory. The great red spot, still visible after hundreds of years, is more than just a hurricane. It is a monument to endurance, It is a poem written in swirling gas, one that never quite finishes its verse. It grows smaller now, yes. Its colour changes, yes, but it remains. And what does it mean for a storm to last so long? Perhaps it is because Jupiter does not forget. Its storms may be the shapes of its thoughts, moving slowly, endlessly across the sky. We see echoes of Jupiter's storms in other places too, on Saturn, Neptune, even Earth. The patterns of air and cloud repeat, though smaller, gentler, less ancient. They are family resemblances in the atmosphere of worlds. They remind us that nature follows rules, but never without grace. The same forces that shape hurricanes on Earth shape the breath of gas giants. Spin, heat, pressure, time, these are the brushes, the planet is the canvas, and the storms are the paintings, always changing, always alive. When we look at Jupiter through telescopes or from spacecraft, we are not just seeing a planet, we are seeing motion, we are seeing history, we are seeing a dream that has lasted longer than any civilization, longer than any language, longer than any star map drawn by human hands. And this dream continues. It deepens with each passing day. New storms appear, old ones fade, patterns evolve. Nothing stays still for long. Yet the feeling of Jupiter remains the same, quiet, powerful, vast beyond measure. There is comfort in knowing that such a world exists, in knowing that somewhere, far beyond our sky, a planet spins with patient storms and silent memory. It reminds us that not all things need to be fast to be strong. Not all truths need to be shouted. Some, like Jupiter, speak softly in the language of winds. Some hold their wisdom in colour and motion, in cycles that never end. And as we study them, we are reminded of our place, not as rulers of nature, but as listeners, learners, quiet observers in a vast and breathing cosmos. Jupiter's storms will go on long after we are gone. They will dance and twist and breathe without us, as they always have, and perhaps that is their gift. Not to teach us everything, but to remind us that mystery is part of the universe's beauty, that some stories, like the swirling storms of a gas giant, are meant to be felt, not solved, to be watched with wide eyes, to be heard like lullabies made of lightning and cloud. So if you ever look up and find Jupiter in the night sky, just a bright point of light among the stars, remember what lies beneath that shining glow. Remember the storms that breathe, the winds that remember, the planet that spins in a never-ending dream. And know as you drift to sleep that somewhere far away, a giant is still dreaming with you. In the hush of the outer solar system, where sunlight arrives like a whisper and the stars shine cold and sharp, Saturn glides in silence. It is not the largest planet, nor the most mysterious, but it is surely the most graceful. Wrapped in a set of rings that shimmer like frozen breath, Saturn moves through space as if remembering something. Its rings are not solid. They are made of ice and rock, scattered and bright, each piece reflecting sunlight that has travelled almost 1 billion miles. And yet, when you look at them from afar, they seem delicate, almost soft, like a dream traced into the dark. They are not only beautiful, they are ancient, and they remember. To understand Saturn is to understand time. The planet spins quickly, completing a day in just over 10 hours, but it takes nearly 30 Earth years to orbit the Sun. In that long, slow journey, its rings catch the light from every angle, casting shadows on the planet and glowing faintly in return. These rings are not a single thing, they are 1,000 pieces, each one orbiting at its own pace, layered in patterns we barely comprehend. They stretch wide, over 70,000 miles from edge to edge, but they are impossibly thin, no thicker than a few stories of a building. If Saturn is the dancer, then the rings are its ribbons, flowing with every turn. Scientists leave the rings of young compared to the planet, maybe just 100 million years old or even less. That is young in cosmic time. Some think they were born from the remnants of a moon shattered by Saturn's gravity. Others believe they were always there, bits of leftover ice that never joined to form a moon. Whatever their origin, the rings have become part of Saturn's identity, as if they were always meant to be there. And they tell us something important, that beauty can emerge from destruction, that light can be remembered long after the source is gone. If you could float among the rings, you would not find a smooth surface. Instead, you would see countless chunks of ice, some no larger than pebbles, others as wide as houses, all moving in quiet orbits. They do not crash. They follow invisible rules, paths shaped by gravity and time. From a distance they seem to glow, up close they are rough and cold. But every surface reflects light, and that reflection becomes part of the ring's story. Each piece, each particle, has been touched by sunlight, and that sunlight carries memory. Saturn itself is a gas giant, like Jupiter, made mostly of hydrogen and helium. But where Jupiter rages with storms and colour, Saturn seems quieter, more subdued. Its clouds form soft bands of yellow, cream and gold. It has storms, yes, massive tempests that can stretch around the entire planet, but they come and go like sighs, less visible than Jupiter's but no less powerful. And beneath those clouds Saturn holds secrets. Its atmosphere stretches deep, layered and warm, moving in slow waves. It may have a rocky core wrapped in metallic hydrogen just like its bigger sibling. And like Jupiter, Saturn gives off more heat than it receives from the Sun. It is still cooling, still changing, still alive in ways we're only beginning to measure. But it is the rings that capture our hearts. They are not permanent. Scientists believe they are slowly falling into Saturn, pulled by gravity, dissolving into dust. One day they may be gone, and Saturn will spin alone again. That thought brings a quiet sadness, like watching an old painting fade. But it also makes the rings more precious. They are not just decoration. They are a moment in time, a fleeting shape in the story of the universe. And right now, they are here. Right now, they shine. The rings affect Saturn too. They cast shadows on its atmosphere, shaping the clouds below. They reflect light back onto the planet, warming it slightly. And they create sounds, radio emissions that we can hear as whispers from space. These sounds are not music, but they have rhythm. They rise and fall as the rings move through Saturn's magnetic field, sending out pulses of energy like quiet heartbeats. We listen and we wonder, what else do the rings remember? Spacecraft have flown through them, most famously Cassini, which spent over a decade studying Saturn and its moons. Cassini dove between the planet and its innermost ring, sending back images and data that changed everything we thought we knew. It showed us the gaps in the rings, the waves, the textures. It saw shepherd moons, tiny satellites that shape the rings with their gravity, keeping them narrow, guiding their flow. These moons, like Pan and Daphnis, dance through the gaps, their paths like footprints on frost. They do not speak, but they shape, and the rings respond. In a way, the rings are a conversation, between Saturn and its moons, between light and shadow, between past and present. Every orbit tells a part of the story. Every reflection is a memory. The rings do not shout, they whisper. They do not stay still, they flow. And in their motion, in their delicate silence, they teach us about the nature of time, about how even something so vast can change, about how even silence can carry meaning. Saturn spins on, its tilt giving it seasons just like Earth. Over the course of decades, the rings rise and fall in the sky, from edge-on slivers to wide-open halos. They catch the sun differently as Saturn moves, lighting up in ways that feel almost alive. Some years we see them clearly, some years they vanish from view, but they are always there, turning, shining, remembering. And when we see them from Earth with telescopes or even with the naked eye, we are looking not just at ice and rock, but at a piece of cosmic memory, a reminder that the universe keeps records, in dust, in light, in the orbits of silent stones. Let's float closer now, not just through space, but through meaning. Saturn's rings may seem simple from a distance, but within them lies a world of delicate complexity. They are not flat like a sheet of paper. They ripple, they twist, they bend. There are places where waves move through the rings like music across a drumhead. These waves are caused by the pull of moons, far and near. Some moons create spiral patterns like the grooves of a seashell. Others carve gaps. These structures are not just beautiful, they are alive with the push and pull of gravity, a dance that never stops, choreographed by forces that have existed since the beginning of time. Inside the rings, every particle is on its own path, and yet they move together like a flock of birds in flight. They orbit Saturn at incredible speed, up to 70,000 kilometers per hour, and yet they do not collide in chaos. Instead, they respond to one another. They adjust, they spin, they balance. If one particle moves too far or too fast, others respond, nudging it back into rhythm. It is a kind of harmony without voice, a physics of peace. It is one of the few places in the solar system where thousands of bodies move together without destroying one another. The rings are divided into sections, each with its own personality. The A ring is wide and bright, filled with strong waves and shepherd moons. The B ring is the thickest, a place of dense mystery where light struggles to pass. The C ring is faint and dusty, more fragile, more ghost-like, and beyond them lies the D ring, close to Saturn's atmosphere, delicate as breath. Farther still are the E, F, and G rings, thin, stretched, some made of particles from distant moons like Enceladus, whose icy eruptions feed the space around it. Each ring is like a verse in a song written by time, and yet despite this beauty, the rings are vanishing. They are being pulled slowly towards Saturn, like petals falling back into the flower that grew them. The ice breaks into smaller pieces, becomes dust, disappears into the planet's gravity. It rains down through the atmosphere, lost forever. Scientists call this process ring rain, and they believe it is steady, gentle, but unstoppable. Some estimates say the rings may be gone in just 100 million years. In cosmic time, that is the blink of an eye. What we see now is rare, a moment, a flicker in the life of a planet. Cassini, the spacecraft that flew through the rings, taught us more than we could have imagined. It found structures shaped by unseen forces, spokes, like ghostly fingers stretching through the rings made by magnetic fields. It saw tiny moonlets forming inside the rings themselves, like baby moons being born from ice. It felt the pull of Saturn's gravity in ways that showed us how the planet spins, how its core might be shaped, how its winds flow from deep within, and finally at the end of its mission, Cassini dived into Saturn itself, vanishing into the atmosphere in a final blaze of data and silence. In that moment, it became part of the story it had spent so long observing. It became a memory, like the particles of the rings, falling into the planet's embrace. And in doing so, it reminded us that even machines can witness beauty. Even metal and wire can carry wonder. Cassini saw the rings not just as objects, but as evidence that nature can be both violent and gentle. That destruction and creation are often the same thing, looked at from different distances. The rings, fragile as they are, affect more than just Saturn. They affect us. They affect the way we think about planets, about beauty, about change. When people first saw them through telescopes, they were stunned. They didn't believe what they were seeing. Some thought Saturn had ears. Others thought it was a triple planet. The truth, that it had a system of rings so perfect and strange, was more beautiful than any guess. And as our instruments improved, the rings became more real. They became not just a mystery, but a message. They tell us that space is not empty, that the universe is full of light and motion, that even in the coldest reaches, where the sun is only a distant glow, beauty persists, that particles can find each other, orbit together, create something larger than themselves. They teach us that time does not erase everything, that memory can live in ice, that light once reflected leaves an echo. Saturn's rings also play with light in ways that feel almost magical. When the sun strikes them at a low angle, they glow brighter. When viewed from behind, they disappear almost completely, turning invisible as the sunlight slips past. And when Saturn casts its shadow on the rings, we see new patterns emerge, shapes that change with the planet's tilt, telling us about its seasons, its spin, its quiet rhythm. The rings are not passive, they are storytellers, they are timekeepers, they hold information in their motion. Scientists read that motion like a clock. They watch how the rings respond to Saturn's gravity, they measure how fast waves move through the ice. From this, they learn how old the rings are, how dense, how they might evolve. Every detail, every flicker of change is a clue, a note in the cosmic symphony that Saturn has been playing for eons. And beneath the rings, the planet itself listens. Its magnetic field shifts slightly with their movement. Its upper atmosphere is touched by the particles falling in. Its clouds brighten or darken depending on the shadows cast by the rings. It is a relationship, not a decoration. The rings are not just around Saturn, they are part of Saturn. And when they're gone, the planet will feel different, lighter, quieter, but it will remember, because planets too can remember. Not in thoughts or words, but in shape, in pattern, in the chemistry of their air, the tilt of their spin, the scars on their surface. Saturn will carry the memory of its rings long after they've vanished. And so will we. we will remember the light, the shimmer, the silence, the way that motion and stillness lived together for a while, balanced on the edge of time. Let us now drift into the final embrace of Saturn's world, where the rings curve gently around the planet like arms caught mid-motion, holding nothing and everything at once. Here, silence is not the absence of sound, it is the presence of balance. Each ring moves with purpose, each fragment orbits with grace. And though we often look at them with the eyes of science, there is something undeniably tender about their existence. They are fragile, yes, they are fading. But in this fragility lives a kind of strength, the strength to endure, to shine, to be remembered. The rings are not just particles of ice, they are the echo of moons lost long ago. They are the shimmer of memory in motion. In the earliest days of our solar system, chaos ruled, worlds collided, asteroids roamed freely, moons formed and shattered. It was during this age, perhaps, that Saturn's rings were born, not in quiet creation, but in the aftermath of something gone wrong. A moon may have come too close, torn apart by Saturn's powerful gravity. Its pieces scattered, settled into orbits, and began the long transformation into the rings we see today. What was once solid became dust and brilliance. What was once one became many, but none of it was wasted. Even destruction here became beautiful. This idea that the rings were born of loss makes their glow even more poignant. When sunlight catches them just right, they radiate like soft fire, bright against the darkness. From Earth they appear serene, but from within they are full of motion. Each particle reflects the sun's light like a mirror held to the past. And in that reflection is the story of everything that came before. The birth of moons, the violence of gravity, the quiet persistence of order. It is a story not written in books, but in the frozen breath of a shattered world, retold again and again as the rings revolve. Saturn listens to this story. Its winds carry the faint rhythm of the rings, its atmosphere marked by strange hexagons at the poles and ghostly streaks of storm responds to the light and shadow they cast. The rings do not float separately. They belong to the planet, drawn and held by forces invisible yet absolute. Their edges are shaped by the shepherd moons, tiny sentinels that maintain the sharp boundaries of chaos. Without them, the rings would blur. But with them, the structure holds. It is a partnership, quiet and patient, where each orbit sustains the whole. And what of the future? The rings are disappearing, yes. Slowly, steadily, they fall. Microscopic particles drift into Saturn's upper atmosphere, burning up, vanishing. We will not see the end, but we can imagine it. One day, perhaps 100 million years from now, Saturn will be bare. The rings will be gone. The planet will continue golden and vast, but changed. And though its clouds will still swirl and its moons will still turn and the space around it will feel just a little more silent, a little more empty, but absence is not the same as forgetting. Saturn will carry the memory of its rings in the tilt of its axis, in the whispers of its winds, in the scars left by falling ice, and we too will remember. Through the images captured by spacecraft, through the numbers written in science papers, through the awe left in the hearts of those who gazed up and saw a ringed world glowing in the night. The rings will be gone, but their story will remain, woven into the history of the cosmos. There is comfort in knowing that nothing lasts forever, but everything leaves a trace. Saturn's rings teach us that beauty does not require permanence, that motion can hold memory, that a thing may be slowly falling apart and still be the most beautiful thing in the sky. The universe is full of such contradictions, of stars that burn out and leave behind light, of black holes that swallow and still shine, of planets that carry broken moons in bands of ice and reflection. And in all this, there is meaning. Not because the universe tells us why, but because it shows us how. How to orbit even when pulled in every direction, how to shine even as you fade, how to hold harmony in 1,000 pieces. The rings of Saturn are a lesson written in orbit, a lullaby in motion. And if you close your eyes and listen, you can almost hear it, the gentle turning of ice, the slow rain of light, the endless hush of a planet remembering. So when you look at Saturn from Earth, whether through a telescope or a photograph or just your imagination, let yourself feel the weight of what you're seeing. You're not just witnessing a planet, you're witnessing a moment, a rare, glowing, fleeting moment in the life of a world. You're seeing memory in motion, light in orbit, beauty that grew from something lost, and you are part of that moment, simply by being here to notice. In the grand, turning silence of space, Saturn's rings continue their slow, graceful fall, and we, in our smallness, are lucky enough to see them while they last. Out beyond Saturn, farther still than the orbits of moons and the reach of most light, there lies a planet wrapped in blue silence. Neptune, the farthest of the giants, spins in the cold shadows where the sun is only a pale coin. Here, distance becomes a kind of music, and Neptune hums a song too low and slow for human ears to catch. Its colour is not just blue, it is a deep, dreaming blue, like the ocean at midnight. It is a blue made from methane and mysteries, reflecting more light than it should, glowing softly in a place where almost nothing glows. And in that glow, in that shimmering frost of distance, Neptune dreams alone. This planet is massive, nearly 4 times wider than Earth, but it hides itself well. Its surface cannot be seen, for it has no solid ground, only layers of atmosphere swirling endlessly, hiding a core that may be rocky or molten or something we've never named. What we see of Neptune are its winds, its clouds, its ghostly bands of gas curling like breath on cold glass. These clouds do not drift gently. They race faster than any winds in the solar system, reaching speeds of over 1,000 miles per hour. Even in silence, Neptune moves with purpose. Even in solitude, it stirs. Its storms appear as dark spots, swirling ovals of shadow that come and go like thoughts in sleep. These dark spots can grow as wide as Earth and vanish within years. They are born from deep in the atmosphere, rise into view, then fade back down, like memories that surface and slip away. Voyager 2 saw one of them up close, a great dark spot with bright clouds around it, white as cirrus on Earth, spinning and trailing behind like the tail of a comet. Since then, other dark spots have been found, each one unique, each one a brief and whispering presence. They are not loud, they do not roar, they glide in the planet's blue hush. Neptune has rings too, but they are faint, dusty, broken. They do not shine like Saturn's, they do not last long. They arc around the planet in uneven strands, pieces of old moons or failed ones, strung together in the orbit of memory. Some of Neptune's moons help shape them. Tiny shepherds like Galatea nudge the particles into place. Others, like Despina, pass so close you could almost imagine them touching the rings, pulling them gently, quietly. And above them all drifts Triton, Neptune's largest moon, a world unto itself, icy, backward spinning and possibly born somewhere else. Triton orbits Neptune in the opposite direction of the planet's spin, a rare and puzzling dance. It may have once been a dwarf planet captured by Neptune's gravity and brought into its quiet fold. Now it moves in slow rebellion, pulled gradually closer, inch by inch, over millennia. One day, Triton will fall. It will either crash into Neptune or be torn apart, forming new rings in the planet's sky. This future is distant but inevitable. The blue planet waits, patient and still, as time flows around it like cold air. The cold here is profound. Neptune receives only 1/900th of the sunlight that Earth does. Its atmosphere is chilled to the edge of what atoms can endure. Yet the planet radiates more heat than it receives. It glows with energy from within, warmth left over from its creation, heat still rising from the ancient collisions and compressions that shaped it. That glow is faint, but it pulses softly, warming the base of the atmosphere and feeding the winds that race across its surface. Like Jupiter and Saturn, Neptune is not passive. It breathes, turns, remembers. And still, Neptune is a planet we know so little about. Only one spacecraft has ever visited it, Voyager 2 in '89, passing by in a brief, graceful arc, capturing images that remain some of the only close looks we've ever had. From Earth, we watch it with telescopes, catching flickers of its weather, glimpses of its storms, its strange spin, its lonely moons. But there is so much hidden beneath the clouds, so many questions that drift unanswered. What lies beneath the blue? What fuels the winds? What secrets rest in its deep, unseen heart? It is easy to think of Neptune as cold and far, but there is something tender in its quiet persistence. It continues, even when unobserved. It turns, even when forgotten. Its storms rise and fade with no one to see. Its winds whisper through invisible currents. Its rings shed particles into space unnoticed. And yet all of it matters. All of it adds to the silent weight of being, to the deep rhythm of the solar system that beats on whether we listen or not. Neptune's beauty lies in its calm defiance. It does not demand attention. It does not shine loudly. It remains soft and slow at the edge of what we can know. A planet of distant dreams, held together by gravity, wrapped in blue winds, touched by the faintest warmth, and circled by shadows. It is easy to overlook Neptune, but once seen, it is never forgotten. Let us now drift even closer into Neptune's quiet body, where colour softens into shadow and wind becomes the language of the deep. This is a world shaped not by land but by layers, gas upon gas, pressure upon pressure, each one hiding the one below. We often imagine planets as solid, as touchable, but Neptune is a place where touch has no meaning. If you tried to land, there would be no ground, only descent, further and further, into the cold embrace of fluid hydrogen and helium, until the line between atmosphere and interior disappears completely. This descent is not sharp or sudden, it is slow, like falling into memory. And in this memory, Neptune keeps secrets. Its clouds high above are shaped by methane, a gas that eats the red light of the sun and reflects back only blue. But beneath these clouds, the atmosphere thickens into storms that travel faster than sound. These are the fastest winds in the solar system, racing across a surface that does not exist, carving invisible paths through air so cold it can freeze breath into crystals. No one knows why the winds move so quickly. Some say it's the internal heat rising up. Others believe Neptune's distant, untouched position allows its energy to remain locked in motion. Whatever the reason, the winds carry history. They remember storms born long ago, and then they continue spinning even as the light around them fades. Deeper still, the pressure rises, turning gas into liquid, liquid into something stranger. Hydrogen and helium press into exotic forms, fluids that may behave like metals conducting electricity, shimmering without form. Scientists believe Neptune may have an ocean beneath its clouds, not of water, but of slushy ice and salt and ammonia. A chemical sea so alien we can only imagine it through equations and guesses. This ocean might churn with storms even more powerful than the ones above, or it might sit still, a silent, glowing layer that hugs the planet's core, holding its heat like a secret. At the very centre, there may be a rocky core, the seed around which the planet formed, but we do not know for sure. It is hidden beneath so many miles of sky that light itself cannot reach it. And yet the evidence of what lies beneath comes through motion. Neptune's magnetic field is tilted strangely, not centred on its core like Earth's. It wobbles, like a spinning top slightly out of balance. This suggests that the magnetic source lies in the middle layers, not the deep centre, a kind of floating dynamo, where ions move through strange matter, creating a field that ripples unevenly through space. This field affects everything around the planet. It traps particles. It shapes auroras, glowing rings of light that flicker over Neptune's poles, invisible to our eyes, but real all the same. The planet is not alone in its orbit. It carries a family of moons, each one different, each one contributing a thread to Neptune's quiet song. There's Proteus, dark and lumpy, Nereid, with its wild, stretched-out orbit, Larissa, close and cratered, but none are like Triton. Triton is the strange child, the adopted one. It orbits the wrong way, hinting at a past that began elsewhere, perhaps in the Kuiper Belt, where icy worlds roam in slow, wide paths. Triton is large, nearly as big as Earth's moon. Its surface is frozen, but active. Voyager 2 saw geysers erupting from beneath its crust, spraying nitrogen high into the sky. This means Triton is not dead. Beneath its icy shell, something stirs. Perhaps there is an ocean beneath that crust. Perhaps heat from the core keeps it liquid, creating a hidden sea where molecules drift and dance in the dark. Some scientists wonder if life in some ancient or strange form could exist there. Not life as we know it. No forests, no fish. But something microscopic, something patient, something that waits. If so, it would be the farthest known life from the sun. A life warmed not by light but by the memory of heat, by the press of gravity and the slow decay of radioactive atoms. And if not life, then still, motion, chemical conversation. a rhythm that makes Triton more than just a frozen stone. All of Neptune's moons contribute to the gravity of the system, tugging on one another, pulling at the rings, shaping the planet's subtle wobble. Even the smallest moons, like Naiad and Thalassa, have roles to play. They move in delicate orbits, passing close, never touching, dancing in patterns so precise they seem choreographed. These orbits are not random. They are the result of time, of balance, of countless interactions over billions of years. They are what remains after chaos settles into grace. Neptune itself moves slowly around the Sun, taking at Earth years to complete a single orbit. That means no human has lived through even one full Neptunian year. Its seasons last over 40 years each. Its solstices and equinoxes are events that stretch across generations. When Voyager flew past in 1989, Neptune was just reaching its southern summer. Now, decades later, it still hasn't reached autumn. The planet changes, but at a pace so gentle it feels like sleep. Its clouds shift, its storms appear and vanish, its brightness waxes and wanes, but its essence remains. And so we watch from afar. Telescopes on Earth and in orbit glimpse Neptune through thin slices of atmosphere. They see its blueness, its clouds, its moons. Sometimes they catch the birth of a storm, the fading of a dark spot, the slow movement of Triton against the stars. These moments are rare, precious. They remind us that even distant things are worth noticing. Even the quietest planets have stories to tell. Neptune teaches us about the beauty of distance, about the dignity of slowness, about the richness of things that do not need to explain themselves. It moves on the edge of our awareness, a ghost in the dark, and yet it is fully real, fully alive, fully present in the ballet of planets. It is not forgotten, it is not lost, it is simply farther, quieter, bluer. And in that blueness is a kind of wisdom, a knowing that does not shout but hums, a patience that does not fade, a solitude that is not loneliness but depth. Neptune turns and the stars move behind it. Its rings shimmer faintly, its winds whisper in the dark, and in every turn, every orbit, every cloud it continues the dream that began long before we looked up. Now let us fall fully into Neptune's stillness, where the cold is ancient, and the winds blow without sound through an ocean of sky. The blue here is not just colour, it is mood, it is memory, it is the quiet of distance made visible. Neptune is a planet far from warmth, far from noise, but it is not empty. It is full of slow stories, of forces too gentle to shout, of rhythms that stretch beyond our lifetimes. And in its deep drifting clouds, we find not only gas and storms, but reflection. Neptune reminds us that the most powerful presences are sometimes the softest. There is a calmness in Neptune's shape, a roundness formed by gravity's hand, turning for billions of years, balancing pressure from within with the pull from without. This shape is not a choice, it is the natural end of time and turning. But the details within that roundness, those are different. The patterns of clouds, the tilt of the magnetic field, the bursts of unseen heat. These are the planet's voice. They speak in waves and pulses, in rotations and pressure fronts. They tell a story with no beginning, no end, only the middle turning endlessly. We do not know when Neptune last saw a visitor. Voyager 2 passed close, but only once, in a fleeting glance. No probe has orbited it, no lander has descended, no human-made object has returned. And yet, the planet continues, whether we look or not. Its moons keep spinning, its winds keep racing, its heart keeps glowing faintly but persistently. The absence of observation has not slowed it. This is Neptune's great lesson, that existence is not dependent on being seen. And yet we do see. We build telescopes stronger, we watch from afar, and sometimes we catch moments of change. A dark spot forming, a storm stretching across the atmosphere, a flicker of aurora at the pole. These are Neptune's sighs, its exhalations. They remind us that something vast and real moves beyond our skies. They call to our curiosity, to our desire to understand what lies beyond the comfortable brightness of the inner solar system. There is something in Neptune's storms that feels familiar, even from this distance. On Earth, we watch clouds shift, feel wind across our skin, and know that weather is alive. On Neptune, that life continues, but scaled to something grander, more enduring. The storms rise from deep below, spiral for years, then fade without a trace. No city is destroyed, no trees are bent, but still they turn, still they breathe. They are not measured by damage but by motion, and in that motion we see the heartbeat of a planet that refuses to rest. Beneath the clouds, the heat rises in ways we cannot see, cannot feel, but it is there, pushing outward, lifting gases into jet streams that slice across the sky. This warmth comes not from the sun, but from Neptune's birth, from the compression of gases, from the slow decay of radioactive materials in its hidden core. It is the echo of an origin, still glowing in the dark. And perhaps that is the most beautiful thing about Neptune. It carries its past within it gently, without rush. Its rings, faint and broken, also speak of time. They are not grand like Saturn's, but they still shimmer in starlight. They still trace paths through Neptune's gravity, curving delicately around the blue globe. These rings are made of dust, of small stones, of debris from shattered moons or captured objects. They are temporary. They may vanish one day, but while they last, they add to Neptune's quiet story, a border, a whisper, a soft halo in the dark. Triton, Neptune's strange companion, orbits in silence, pulled gradually closer over the ages. Someday, perhaps millions of years from now, Triton will fall apart. It will be ripped by Neptune's gravity and spread into a ring, a new one, brighter, younger. This future ring may shine more clearly than the current ones. It may stretch wide, curve with symmetry, catch the sun's light like frozen poetry. But for now, Triton remains whole. It moves backward through the sky, cold and curious, carrying its own secrets beneath an icy crust. And in all of this, the winds, the heat, the rings, the moons, Neptune continues to teach. It shows us how a planet can be active without violence, how a world can be rich without sound, how distance does not equal emptiness. It teaches us that the universe is not only made of stars and fire, but also of quiet, cold giants that drift through space with grace. Neptune does not demand our attention. It does not flash or roar. It simply is, and in being it gives us perspective. It helps us see our own world differently, not as the centre, but as one of many, not as the loudest, but as part of a harmony. The solar system is a symphony, and Neptune is one of its lowest, softest notes. It hums through space, steady and strong, whether we are listening or not. And yet we do listen. We build better eyes to see it, better ears to hear its signals. We imagine missions, orbiters, flybys. We dream of new photographs, of new maps, of new knowledge. We want to understand, and that desire connects us to Neptune, not physically but emotionally. We too are made of storms and silence. We too move through space, through time, through change. When you think of Neptune, think not only of its cold or its distance. Think of its patience, its dignity, its blue solitude. Think of the way it turns endlessly in the dark, holding heat in its heart and storms in its sky. Think of the memory it carries, the mystery it preserves. And know that in every breath of wind, on Earth or elsewhere, there is something of Neptune, a softness, a strength, a reminder that even the quietest planets have stories worth hearing. There is a place on Jupiter where time seems to have curled inward, where colour churns in slow fury, and the air never truly rests. This place is the Great Red Spot, a storm so vast it could swallow Earth whole and still have room to turn. It is not a mountain, or a crater, or a mark on the ground. It is a wound in the sky, a spiral of clouds that has been spinning for at least 300 years. It drifts across Jupiter's atmosphere like a memory that refuses to fade, burning red and rust and pink against the planet's bands of beige. To look at it is to see the persistence of motion. To study it is to hear the breath of a world made of gas and lightning. This storm is not still. It is not frozen into place. It moves. It changes. It grows smaller some years, larger in others. Its colour deepens and softens, then brightens again, but always it remains. It has seen empires rise and fall on Earth. It has watched us develop telescopes, send probes, fall in love with the skies, and yet it continues spinning in silence. It has no sound, no scent, no beginning we can point to, But in its turning, it tells the story of Jupiter, not in words, but in motion, in colour, in endurance. To stand near the great red spot would be to feel nothing beneath your feet, because there is no ground. Only wind, layers of it, each moving in different directions, wrapping around the planet in long, flowing bands. The spot sits between two such bands, caught in the tug-of-war between opposing jet streams. This tension feeds it, sustains it, carves it into its spiral shape. The winds inside the spot reach speeds of over 400 miles per hour. Clouds rise and fall within it. Lightning crackles in its depths, and yet from afar it looks almost still, like a fossil in motion. Its colour, that iconic red, is still a mystery. Some scientists believe it's caused by sunlight reacting with the gases high in Jupiter's atmosphere. Ammonia, hydrogen, perhaps even sulfur. Others think it may be due to compounds dredged up from deep below, exposed to radiation, and transformed into something rich and rusted. Whatever its source, the colour has changed over time, shifting in hue and brightness, as if the storm is breathing in and out through light. Above the great red spot, thin white clouds race past. These clouds form when ammonia in the upper atmosphere cools and condenses, creating bright streamers that stretch around the storm's rim. They trace its edge like lace, delicate against the swirling mass below. These upper layers are colder, thinner, touched by sunlight. But deeper down, the storm grows hotter, denser, more chaotic. We cannot see the bottom of the great red spot. No camera has pierced that far, but data suggests it reaches hundreds of miles into Jupiter's depths, a churning column of gas and heat and hidden energy. The storm moves westward, slowly circling the planet. It completes a loop every few Earth days following Jupiter's rapid rotation. As it drifts, it leaves wake patterns behind, ripples in the atmosphere that fade and reform. Smaller storms sometimes collide with it. Some are absorbed, vanishing into the greater spiral. Others pass unmatched, as if too small to matter. But none have destroyed it. None have stopped it. The great red spot endures, and in doing so it becomes something more than a storm. It becomes a symbol of the planet itself, vast, powerful, unknowable. There are other storms on Jupiter, but none like this one. Others come and go in weeks or months. The spot has lasted for centuries. It is older than the idea of electricity, older than the first telescope that saw it. It may be older than we know how to measure, and yet it is not immune to change. Over the past few decades, it has grown smaller. It once stretched wide enough to hold 3 Earths. Now, it holds just one. Its edges are tighter, its shape more oval. Scientists debate what this means. Is the storm dying? Is it evolving? Or is it simply pulsing, responding to cycles we don't yet understand? Whatever the answer, the Great Red Spot teaches us something about resilience, about persistence, about the way energy can find a shape and hold it through time. It reminds us that not all life moves with haste, that some things endure by turning slowly, steadily, without pause. It is a storm, yes, but it is also a monument, a landmark in the shifting skies of a gas giant. And as we float above it, in imagination or in the data of distant spacecraft, we see not chaos but order. The spiral is precise, the winds follow rules, the clouds respond to forces we can map, measure, model. Within the storm there is structure, there is rhythm, there is a kind of peace, even in the fury. And that perhaps is its greatest mystery, that a storm of such power can also seem serene. In the shadow of the Great Red Spot there is no darkness, there is only turning, and turning, and turning still. Let us now drift deeper, beneath the thin lace of white cloud tops that border the Great Red Spot, and into the slow, powerful spiral itself. Here, the winds are not just weather, they are inheritance. Layer upon layer of atmosphere spins in concert, some rising, some falling, all bound together in a shape that persists beyond human time. We do not know when this storm began, only that it has never stopped. It rotates counterclockwise in Jupiter's southern hemisphere, caught between bands of faster-moving winds flowing east and west. This contrast in direction traps the storm, holds it in place, feeds it. It is as if Jupiter, with all its endless swirling, has chosen to hold one motion sacred, to let it spin and remember. Within the spot, gases are stirred and lifted, creating towering cloud structures shaped by the planet's rotation and heat. The deeper layers of the storm are hotter, more massive, and shrouded in darkness. We cannot see them directly, but spacecraft like Juno have peered into the depths with instruments that sense gravity and microwave radiation. What they found was astonishing. The Great Red Spot may extend 200 to 300 miles downward deep into the planet's lower atmosphere, far beyond what Earth storms can reach. On Earth, a hurricane might scrape the top layer of the ocean or the upper levels of the atmosphere. On Jupiter, this storm dives into the depths of a planet without a surface, stretching toward a core no one has seen. It is easy to imagine storms as chaotic, but the Great Red Spot moves with surprising elegance. Its boundaries are sharply defined, its core is calm compared to its edges, where the fiercest winds scream around in circles. In this way, it resembles a massive eye, focused, centered, even graceful. Around it, smaller storms form and vanish, drawn into its gravity like moths to a candle. Some merge it into the spot, adding to its mass. Others skim past, tossed aside, scattered, like thoughts too light to stay. This constant interaction gives the spot its texture, its evolving edge, its endless ripple of white and amber curls. The colour of the Great Red Spot is not fixed. Over time it shifts. Sometimes it is a deep rust-red vibrant against Jupiter's pale background. Other times it fades to salmon or peach. The reasons are still debated. Sunlight likely plays a role. Ultraviolet rays break apart chemicals high in the atmosphere, creating compounds that reflect red light. Ammonia and phosphorus may be involved, or sulfur, or unknown materials rising from deep within the planet. The winds themselves may lift particles from below, or strip others away. The result is a colour that is alive, one that changes like breath, slow and quiet over years. Jupiter's atmosphere is not layered like a cake, it is more like a symphony, each instrument playing its own part but altogether forming something complex and beautiful. This Great Red Spot is one of the loudest instruments in that symphony, not because it shouts, but because its presence lingers. Even the planet's magnetic field may be shaped by the storm's depth and movement. As charged particles swirl in Jupiter's vast interior, their patterns can be disturbed by the slow churn of gases within the spot. Some scientists wonder if the storm affects the deeper flows of hydrogen that become metallic under pressure, flows that may create the powerful magnetosphere surrounding Jupiter like an invisible shield. From space, the spot appears almost painted, perfectly elliptical, nestled between swirling belts of cloud. But from closer, it is full of texture. Bright spots emerge, stretch, dissolve. Vortices form along the edges, spinning in the opposite direction. These features rise and fall, sometimes disappearing in hours, other times lasting for days. It is a world within a world, a storm big enough to have its own storms, its own life, its own sense of time. The Great Red Spot may be ancient, but it is not immune to change. Observations show that it is slowly shrinking. It used to be over 25,000 miles wide. Now, it is closer to 10,000. Its height may also be decreasing, making it flatter, more compact. No one knows why. It may be losing energy as it merges with smaller storms, or as winds around it change speed. Some believe it will vanish within our lifetimes. Others think it will stabilize at a smaller size. But even if it fades, its memory will remain, in data, in images, in the sky of Jupiter's past. There are other red ovals on Jupiter, smaller versions that spin in similar ways. Some have lasted decades. One, called Oval BA, formed in 2000 when 3 smaller storms merged. It too changed colour over time, briefly becoming a reddish hue. These smaller storms show that the dynamics of the Great Red Spot are not unique, but the scale is unmatched. It is as if Jupiter occasionally tries to recreate the Great Storm, like echoes or sketches of a masterpiece. But none have lasted as long. None have held the same place in the planet's identity. When we speak of the Great Red Spot, we are speaking not just of a feature, but of a phenomenon. A living, shifting monument to the power of weather on a scale our world cannot imagine. It is larger than landscapes. It outlives cities, civilizations, even languages. It spins while we sleep, while we wake, while we forget. And it is not silent. Not truly. It emits radio waves, shaped by the planet's magnetic field and by lightning deep within its clouds. These signals travel through space like ghostly music, faint but persistent, waiting to be heard. In the swirling gases of the spot, we see not just a storm, but an idea made real. That motion can endure, that form can survive without being fixed, that change can be slow and strong at once. It tells us that time is not just something we count. It is something we feel in the turning of planets, in the breath of storms, in the curves of clouds that remember their shape. Now, let us descend fully into the hush beneath the great red spot, not in body, but in thought. Imagine falling not through air, but through history, through colour, through soundless motion. The storm spins on, unconcerned by time. Its shape, changing yet familiar, is like the curve of a seashell, each layer a memory of the one before. The spot may be shrinking, but it does not vanish. It remembers its vastness, remembers the centuries, remembers the silence before we ever looked up. And in that remembrance it lives. As we go deeper into Jupiter's atmosphere, the gases thicken. The ammonia and hydrogen blend with heat and pressure, forming clouds that swirl unseen beneath the visible layers. These are not clouds as we know them, not puffs or blankets, but rivers, writhing in slow rolls shaped by temperature, pulled by gravity. In this depth, light becomes rare. Here, the storm is not red or white or peach. Here, it is colourless, a dance of force and mass. The molecules move in long spirals, cradled by heat from below. This heat is ancient, left over from Jupiter's formation. It pushes upward while gravity presses down. In between, the storm breathes. We often think of breathing as something lungs do, but here breathing is the rise and fall of gas. It is the motion of pressure equalizing, the lifting of warm materials, the descent of cooler ones. In the great red spot, this breath never stops. It is slower than ours, deeper than ours, but just as constant. And in that breath is rhythm. And in that rhythm is a kind of life. Not life like plants or creatures, but life like pattern, like balance, like enduring motion. The storm is older than most of what we call history. It was there before we had maps of Jupiter, before we knew the planet had moons, before we understood what planets were. The first telescopes saw it as a mark, strange red, slowly shifting. Later it became an object of fascination. Probes flew past and circled, watching, measuring. They saw how it spins, how it thins at the edges, how its heart stays strong. They sent back data, images, numbers, but they could not capture the experience of the storm itself. That belongs only to the storm. And now we know the spot is shrinking. Slowly, quietly. It no longer holds 3 Earths across, but still it turns. And in this shrinking there is no defeat. There is only transformation. Perhaps the storm is becoming something else. Perhaps the energy that fed it is flowing into new shapes, new patterns yet unseen. Jupiter has many such features. Bands of wind, chains of smaller storms, filaments of cloud that stretch and coil. The great red spot may become one of these, or it may vanish entirely, returning its colour and energy to the planet that made it. In either case, its memory will remain. The memory lives in us too, in the photographs taken by passing spacecraft, in the telescopes that still watch from Earth, in the words we write and the maps we draw, but it also lives deeper in the way we imagine the sky. When we think of Jupiter, we do not picture a smooth sphere. We picture the spot. We picture that storm, endless and turning, like a heartbeat written in cloud. It has shaped our image of Jupiter. It has become a symbol of motion without violence, of strength without noise. There is something deeply peaceful about watching a storm that lasts for centuries. On Earth, storms are brief and often destructive. They come and go in days. They flood, they break, they roar. The great red spot is different. It does not scream. It does not end. It does not destroy. It simply moves. Its energy does not scatter outward. It stays contained in the spiral, held in place by Jupiter's vastness. It is like a thought that never fades, like a dream the planet continues to dream. What would it be like to drift above that storm? Not in a ship, not with instruments, but simply as a presence, weightless, timeless, hovering in the thin air above the spinning vortex. You would see the edges twist, the white clouds flowing like waves curling on a slow ocean. You would hear nothing. There is no sound in Jupiter's skies, only motion, only rhythm, and as you float you might begin to feel the scale, not just the size of the spot, but the depth of its time. You would realize that you are watching something that began before the age of flight, before the age of steam, before cities had lights or names, and it would still be turning. In this quiet, you would feel the presence of all the storms that came before, the echoes of vanished ovals, the ghosts of tempests lost in the clouds. Jupiter remembers them all, though it never says their names. It holds them in its wind, in its pressure, in the way its belts shift and slip and return. The Great Red Spot is not just a storm. It is a chapter in that remembering. It is a pause in the melody, a low note sustained across centuries. One day, perhaps soon, it may be gone. Future telescopes may look at Jupiter and see only bands, clouds, smaller spots. They may not find the familiar red eye, and those who never saw it may not miss it, but we will know. We will remember that once a storm circled for 300 years and more, that once a planet held a piece of itself in swirling colour and let it spin, unbroken. And that memory will be enough. Because in the end, the Great Red Spot is not just weather, it is a reminder that motion can outlive its cause, that time can hold shape, that planets, though made of gas and light, can still leave marks that echo, and that somewhere in the sky, high above the clouds of Jupiter, a storm once turned and turned and turned. Far beyond the clouds of Earth, beyond the orbit of Mars and the belts of drifting rock, there are moons that do not shine on their own. They reflect borrowed light, soft, pale and cold. Around the gas giants of our solar system, these moons drift in quiet paths, each one unique, each one carrying a story written not in language, but in ice and rock and silence. Some are large enough to hold oceans, others are tiny tumbling stones with no air, no warmth. But all of them listen. They move through the dark, circling worlds that thunder with storms, absorbing the echoes of gravity and time. These are the silent moons that listen. They do not speak, but they remember. Among them is Europa, a moon of Jupiter, smooth and pale like an eye turned toward the void. Its surface is a sheet of cracked ice, stitched with long, dark lines. These are not rivers or canyons. They are fractures in the ice filled with salt and perhaps warmth from below. Beneath this frozen skin lies an ocean, deep and wide, held liquid by the heat of Jupiter's pull. Europa is small, but it listens closely. It listens to the groans of its ice, to the pressure of tides rising and falling in the dark. It listens to the whisper of its ocean, which may hold more water than all of Earth's seas combined. And perhaps, in that black, buried sea, something else listens back. Then there is Enceladus, the gleaming moon of Saturn, white as snow and marked with stripes like tiger's claws across its south pole. From those stripes, called tiger stripes by scientists, jets of water erupt into space. These geysers are more than just ice. They are signs of an underground ocean, warmed by the friction of Enceladus's orbit. The plumes reach high into space carrying salt and even simple organic molecules. A spacecraft once flew through them, tasting their spray like a hand catching snowflakes. And what it found was stunning. Chemistry that could support life. Enceladus does not boast. It does not sing. But it tells its secrets in vapour. It listens, and it responds with a whisper. Triton, the largest moon of Neptune, is another listener. It spins backward, a moon caught by gravity, not born of its planet but stolen from elsewhere. Its surface is frozen nitrogen, smooth and cold with dark streaks and geysers that erupt from below. These geysers are not heated by sunlight. Triton is too far from the sun. Instead, the heat comes from within, from the slow decay of radioactive elements, from the memory of its captured path. Triton's orbit is slowly spiralling inward. One day, it will either crash into Neptune or be torn apart, becoming a ring. Until then, it circles in silence, watching the blue giant beneath it, listening to the gravity that guides its fate. Even Ganymede, the largest moon in the solar system, listens. It is bigger than Mercury, wrapped in rock and ice, with a hidden magnetic field of its own, a rare thing for a moon. Beneath its surface may lie a salty ocean. Above, its crust is scarred with ridges and grooves, the marks of ancient movement. Ganymede feels the pull of Jupiter's magnetosphere, a swirling bubble of charged particles. It reacts. It holds. It turns. Its surface may be still, but inside things shift. Moons like Ganymede do not roar or burst. They wait. They adapt. They carry the silence of age, shaped not by fire but by the long gravity of time. These moons and others, Callisto, Rhea, DNA, Miranda, form a constellation of listeners. They orbit quietly, circling planets that spin with enormous storms. They feel the tides rise and fall, they hear the magnetic fields pulse and shift. Some crack with the strain, some erupt, some freeze completely, but none of them drift without purpose. Their paths are held by gravity, their surfaces shaped by ancient impacts, their cores warmed by invisible friction. Even in stillness they are part of the dance. Even in somnus, they are alive with memory. Moons do not need to shine to be noticed. They reflect what they receive, and what they receive is a story of heat, of pull, of presence. They move in resonance with their planets, their orbits tuned like instruments in a celestial symphony. Some moons share orbits, moving in lockstep in a way, never colliding. Others skip ahead and fall back, caught in rhythms older than thought. These patterns are not chaotic. They are ancient agreements, the balance of force and mass and time. When we look up and see a planet, we often forget its moons, but they are always there, circling steady. They remind us that not all things in the universe are loud. Some listen, some record, some endure without change for 1 billion years, and in doing so they become our windows into the past. When spacecraft fly by and take pictures, when sensors measure gravity or magnetism or heat, it is the moons that offer answers. It is the moons that preserve the clues. These silent moons are not barren. They are not lifeless stones. They are libraries, holding the pressure of ancient tides, the chemistry of lost oceans, the scars of forgotten impacts. They carry the fingerprints of the solar system's birth. They show us what happens when time is allowed to work slowly, without interruption, and they offer the possibility that somewhere in their hidden waters, life may have quietly begun, waiting in the dark, not to call out, not to build, but simply to be. Now let us drift more deeply among the silent moons into the sand space between them, where gravity hums like a low lullaby and motion becomes the only voice. The moons listen not just with their surfaces, but with their entire being. They listen with their ice, with their oceans, with their fragile crusts that shift and stretch beneath the weight of tides invisible to the eye. In these stretches of time and space, silence is not emptiness, it is patience. It is the slow, faithful tracing saying, paths across the sky, each moon returning again and again to the same place, drawn by the pull of planets older than memory. Europa, with its glassy skin and hidden sea, speaks in patterns. Its surface is etched with lines like the veins of a leaf, like cracks in the frozen glass that form slowly, then freeze in place. These fractures aren't just marks, they are traces of movement from below. The ice moves, pushed from within by the tides of Jupiter's gravity, stretched and pressed and pulled in rhythms that go on forever. As the moon orbits, it is flexed by this force. The heating caused by this flexing keeps its ocean liquid beneath the crust, and in that dark buried ocean where no light ever reaches, may dwell a world untouched by air, by fire, by anything we know. We do not know what swims there, if anything does, but we know that the conditions are right, that warmth and water exist in a place where life could wait, quietly for eons. Enceladus listens too, in another way. Its plumes do not rise once, they rise continuously, spraying fine mist into space with every orbit. The material escapes through the tiger stripes on its south pole, carried upward from the hidden sea below. Some of this material falls back onto the surface, making Enceladus one of the most reflective objects in the solar system, so bright it seems to glow. The rest escapes into Saturn's orbit, forming part of the E-ring. These eruptions are not violent. They are gentle, consistent, soft. And through them, Enceladus tells us what it holds inside: salt, silica, simple organic molecules. These are not fireworks. They are whispers. And the more we listen, the more we understand. Ganymede, largest of them all, has a strange voice, magnetic, layered, low. Unlike most moons, it has its own magnetic field, suggesting a liquid iron core beneath its icy shell. This field interacts with Jupiter's powerful magnetosphere, creating auroras, faint glowing lights that shimmer at its poles. These auroras shift, tilt, move. By studying their motion, scientists can learn about the ocean that lies beneath Ganymede's crust. It is like watching the ripples on a pond and learning about the stones beneath the surface. Ganymede says little, but when it speaks in waves. Triton, cold and far, listens in reverse. Its orbit moves against Neptune's spin, a slow backward spiral through a sky so distant it feels forgotten. And yet Triton remembers. It holds on to heat from within, enough to drive plumes of nitrogen high into the air. Its surface is smooth, young, wiped clean by ice flows and slow geysers. It is a moon remade again and again, and though it will one day fall into Neptune or become a ring, for now it endures. Its stillness is not surrender, it is survival. Some moons listen by not changing. Callisto, another of Jupiter's moons, is ancient and untouched. Its surface is covered in craters, layer upon layer, each one a mark of a moment in time. It has no deep ocean, no internal movement. But in that stillness, it holds something rare, the unbroken memory of billions of years. It is a record, a stone tablet written by the solar system's earliest days. While other moons shift and melt and erupt, Callisto remains, a quiet witness to everything that has come and gone. Each moon has a story. Some hold oceans, some hold scars, some reflect light like mirrors, others vanish into shadow, but all of them are part of a conversation without words carried in orbit and motion. They do not speak as we do, they do not build or write or send messages, but they listen, they respond. They turn in time with their planets, in resonance, in harmony. Sometimes their silence is broken, not by them, but by us. We send spacecraft to fly by, to measure, to photograph. We drop instruments, we catch particles in space, and through these missions the moons begin to speak more clearly. When the Cassini spacecraft flew through Enceladus's plumes, it gathered a library of chemical clues. When Galileo orbited Jupiter, it measured the magnetic pull of Europa and Ganymede, learning what lies beneath. Even now, new missions are being built, Europa Clipper, JUICE, to return to these quiet worlds and listen better. We are learning how to listen to what cannot be heard. There is beauty in this, in the quiet moons, in their orbits that never waver, in their surfaces that change only slowly, in the way they reflect the light of their planets, carrying it across the void. They remind us that listening is an act of presence, that to orbit is to attend, that silence is not absence, but attention. The moons wait, and in their waiting they gather meaning. We often search for noise, for signs, signals, bursts of energy, but sometimes meaning comes from what is not said, from what is not done, from what stays steady when all else changes. The moons teach us that there is strength in stillness, that patience can reveal truths, that to endure quietly is its own kind of grace. As we continue to explore, to build machines that listen better, we may one day find life beneath the ice. We may one day land softly on a silent moon and hear, at last, the faint echo of something not made by us. But even if we never do, even if the oceans are empty and the plumes are sterile, the moons have already spoken. In their silence, in their motion, in the long, steady orbit of time. Let us now stay a while longer among these silent moons, not as visitors looking for signs, but as fellow listeners, learning from their patience. These moons have existed longer than our stories. They have turned through cold space in orbits older than our oldest myths, and still they continue, steady, unhurried, unchanged in their devotion to the giants they follow. There is something holy in that motion, something sacred in the way they do not ask to be seen. They simply are, and in being, they show us a different kind of life, a quiet life, shaped by gravity, time, and stillness. The moons are not only companions, they are witnesses. They have watched their planets age, their atmospheres shift, their rings fade or form. They have seen storms gather and vanish, watched comets pass too closely, felt the ripple of distant impacts in their thin crusts. Some bear the scars of that watching. Craters stretch across their surfaces, each one a mark of something ancient. But not all marks are from violence. Some are from water. Some are from heat. Some are from the slow movement of ice that breaks and reforms like thoughts that take millennia to complete. These moons hold those thoughts. They cradle them in frozen silence. There is intimacy in their orbits. Moons like Io, Europa, and Ganymede are locked in resonance. For every orbit of one, the others move in precise ratios. One goes around twice and the next goes around once and a half, and so on. This rhythm is not coincidence. It is the result of gravitational embrace, a balancing act that keeps them in line, in touch, in tune. Through these connections, heat is generated inside their bodies. The friction of motion becomes warmth. And warmth in these distant places is everything. It is the difference between lifeless ice and a world that might stir in the dark. This stirring may never rise to the surface. It may stay hidden, like a whisper beneath layers of stone. But the moons do not mind. They do not perform. They do not race to be known. They move at their own pace, keeping time with the planets, responding to forces larger than themselves. Their silence is not empty. It is full of gravity, of weight, of meaning. Even the smallest ones, the irregular rocks that spin end over end like forgotten pebbles, have paths shaped by ancient collisions, by long-lost orbits, by the same physics that holds galaxies together. Some moons carry their own mysteries. Miranda, a moon of Uranus, is torn and folded like a patchwork quilt. Its surface looks as though it broke apart and came back together again. Scientists wonder what happened. Was it shattered by impact and then reassembled by gravity? Was it heated and frozen again and again until the crust rearranged itself? We don't know, but Miranda holds that story in its cliffs and valleys. It carries a kind of quiet defiance, the will to stay together even after being broken. It listens to Uranus, whose tilt is so strange that its seasons last decades, and it turns in response, always facing the same way, always watching. Other moons, like Mima's with its single vast crater, look like symbols, simple, round, scarred. But even that simplicity is misleading. The crater may have nearly shattered the moon. The vibrations from the impact could have cracked its interior, changed its orbit, stirred its core. What we see is only the surface. Beneath, the stories continue, hidden in silence. In the cold light of Saturn, Mimas turns slowly, bearing its mark like a memory etched in ice. The silent moons teach us something the noisy world often forgets, that presence does not need performance, that to witness is enough, that stillness is a kind of participation. They do not compete for attention. They do not erupt unless pressed. They do not shine unless touched by a light. And yet they shape the world around them. Their gravity carves the edges of rings. Their motion stirs tides on their planets. Their geysers paint space with water and salt. Even their absence can speak. A missing moon can explain the gaps in a ring. A lopsided orbit can reveal a past collision. Every detail is a clue. We study them not just because they may hold life, but because they already hold meaning. Even if no creature ever swims in Europa's ocean, that ocean matters. Even if Enceladus's plumes hold only chemistry, that chemistry matters. They tell us what is possible. They stretch the boundaries of what a moon can be. They offer silence not as emptiness, but as invitation. To pause, to notice, to reflect. And when we look up, when we see the speck of Jupiter, the faint shape of Saturn, the glimmering point of Neptune, we must remember what circles them. The moons are there, even when we cannot see them. They orbit in the shadows, patient and steady. And if we listen carefully, we can almost feel their presence, not loud, not bright, but constant. They are the keepers of rhythm, the holders of hidden oceans, the ancient listeners of the solar system. One day we may land on them. We may drill into their ice, swim in their seas, walk on their ridges. We may leave our footprints, but even then their quiet will remain. They will continue to turn, they will continue to watch, they will continue to remember. And we, for a moment, will become part of their long and silent story. In the vastness of space where no air carries sound and no ear can hear a whisper, there is still music. It does not travel as voices do. It is not strummed or blown or struck, but it exists, deep and wide and unending. It moves through invisible lines, shaped by magnetism and motion, flowing through the gas giants like breath through lungs. This is the song of the giants, Jupiter, Saturn, Uranus, Neptune, and it is sung not in melody but in fields, magnetic fields. Lines of force that stretch through space, twist with the planet's spin, and ring with particles that race through the void. These planets do not speak in words, but they hum with energy, and the song they sing is the quiet song of power wrapped in silence. Every planet in our solar system has a magnetic field, but the gas giants hold the strongest and strangest ones. Jupiter's is so immense it stretches millions of kilometers into space. It would look like a great glowing flower if we could see it, petals of charged particles streaming out in loops and arcs. Saturn's field is more subtle, more mysterious, almost perfectly aligned with its spin. Uranus and Neptune are stranger still. Their magnetic fields are tilted, lopsided, twisted like ropes left in wind. None of them are simple, none of them are still, and all of them sing. They sing in the way electrons spiral along invisible lines, in the way plasma surges and dances, in the way particles from the sun, solar wind are caught and redirected, slamming into planetary atmospheres and making them glow. We call those glows auroras. On Earth we see them as northern lights, but on Jupiter and Saturn they are grander, deeper. They swirl around the poles in giant ovals burning in ultraviolet and infrared light. To the eye they would be invisible, but to our instruments they are bright, electric, alive. Jupiter's auroras are powered not just by the sun but by its moon Io. Io is volcanic, bursting with activity, throwing sulfur and gases into space. These gases become ionized, charged, and caught in Jupiter's magnetosphere. They spiral inward, drawn to the poles, and crash into the atmosphere. The result is a never-ending auroral storm, a light that pulses and flickers in time with the turning of the planet. This is a duet between world and moon, between gravity and heat, between rock and gas. It is one of the clearest songs in the solar system, and it never stops playing. Saturn's song is quieter, but not less powerful. Its field is smoother, more symmetrical, more elegant. Yet even this elegance holds mystery. For decades, scientists tried to measure Saturn's day by listening to the pulses of its magnetic field. But unlike Jupiter's, Saturn's field did not give clear beats. It shifted. It changed. Its rhythm danced and faded. Some think the icy particles from Saturn's rings interfere, making the signal faint. Others believe the answer lies deeper, in the fluid metallic hydrogen that moves beneath the clouds. Whatever the cause, Saturn sings a quieter tune, one that shifts like a whisper in a dream. Uranus and Neptune are even stranger. Their magnetic fields are not centered. They are tilted wildly, off-axis, asymmetric, unpredictable. As they spin, the fields wobble, like tops with uneven weight. This means that their magnetospheres twist and flex through space, sweeping through the solar wind in changing shapes. The result is auroras that flicker and shift, glowing in brief pulses, hard to catch, harder to study. These planets sing like flutes with broken reeds, unsteady, haunting, beautiful in their unpredictability. We cannot hear these songs directly. They do not move through air, but spacecraft can sense them. Voyager, Cassini, Juno. They detect the charged particles, the magnetic pulses, the shifting waves of energy. When translated into sound, these signals become eerie, harmonic, full of rising tones and sudden bursts. The song of a planet, once heard, feels both alien and familiar. Like wind from another world, carrying stories we almost understand, these magnetic fields do more than sing. They protect, they shape, they influence moons, rings, and atmospheres. Jupiter's field traps radiation so intense that any unprotected spacecraft would be quickly destroyed. Its field creates a bubble in space, a magnetosphere, that dwarfs the sun in size. Inside it, moons orbit, particles spiral, storms rage in radio waves. Saturn's field is calmer but still vast. It reaches far beyond the rings, shaping the flow of plasma from its icy moons. Uranus and Neptune, though distant, still carve out space around them, resisting the solar wind like invisible shields. Each of these fields comes from deep within. Beneath the clouds, hydrogen is pressed so hard that it becomes metallic, flowing like liquid metal, conducting electricity. As the planet spins, this metallic hydrogen moves, creating a dynamo, a self-sustaining generator of magnetism. This is the engine of the song. This is the heart of the field. It is seldom unseen, but vital. Without it, the planets would be naked to the wind, stripped by the sun, quiet in every way that matters. And so the giants sing. They sing in lines and loops, in pulses and flows, in particles and light. They sing without sound, but their song fills the space around them. It touches their moons, paints their skies, sculpts their rings. It reaches out to the edge of their reach, touching the solar wind, pushing back against the tide. It is a song of presence, a song of motion, a song of silence turned to force. We listen, and we hear not just data, but rhythm. We hear pattern. We hear power wrapped in silence. And as we drift among the giants, we begin to understand that the universe is not quiet after all. It's full of songs. Some are soft, some are slow, but all of them matter. All of them remind us that energy does not need volume to leave a mark. Now let us drift inward, through the invisible pathways traced by the gas giants' magnetic fields, into the hidden structure of their songs. Though we cannot see these fields with our eyes, they are as real as the wind on Earth, and far more vast. They twist and spiral from the planet's poles and equators, expanding outward in graceful arcs. Charged particles, caught in their grasp, follow these lines like dancers on invisible threads. Some spiral toward the poles, colliding with upper atmospheres and lighting up auroras that never cease. Others are flung into space or gathered into belts, trapped in endless motion around the spinning core. In Jupiter's case, these belts form zones of deadly radiation, dense with particles that move near the speed of light. They create storms not of water, but of electrons. The spacecraft Juno, designed with layers of shielding, flew carefully through these regions, mapping the intensity, listening to the crackle of particles moving across magnetic lines. The instruments aboard turned the data into sound, revealing haunting tones, rising whistles, deep throbs, pulses like faraway thunder. These are the notes of a storm that never ends, a storm made not of clouds but of fields. Saturn, quieter but just as complex, surrounds itself with a field almost too symmetric to explain. Most magnetic fields tilt slightly from their planet's spin axis, but Saturn's does not. Its field is nearly aligned, as if hidden deep within the planet is an engine of perfect balance. This baffled scientists for years, because magnetic fields are typically created by swirling layers of metallic fluid, and that swirl usually gives rise to some tilt. But Saturn's calm field seemed to suggest otherwise, that the currents run deeper, smoother, quieter. Even the rhythm of its field changed over time, confusing scientists who tried to use it to measure the length of a Saturnian day. This planet, so grand and visible, keeps its true spin rate wrapped in magnetic mystery. Meanwhile, Uranus and Neptune refuse all simplicity. Their fields are tilted wildly, offset from their centers, rotating like tops about to tip. Uranus's magnetic field is inclined about 59 degrees from its rotational axis, and Neptune's is tilted 47 degrees. This means the fields sweep around like glowing arms, pushing through the solar wind in lopsided bursts. The resulting magnetospheres are uneven, unstable, shifting in shape and size as the planets spin. These warped fields create unique auroral patterns. No neat ovals here, but bursts and curls that flicker and fade. It is as if these planets sing in broken chords, harmonic but unexpected, their music bending with every spin. What causes these strange fields? Deep inside, the gas giants do not have iron cores like Earth. Instead, their intense pressure turns hydrogen into a strange liquid metal. This metallic hydrogen flows and moves, conducting electricity. That movement, combined with the planet's rotation, generates magnetic fields through a process known as the dynamo effect. In Jupiter and Saturn, this layer is thick and active, spinning quickly, wrapped in gravity. In Uranus and Neptune, it may be thinner or layered differently, contributing to their tilted fields. Whatever the internal arrangement, the effect is the same, planets humming with unseen force. This force reaches far. Jupiter's magnetosphere stretches so far into space that if it were visible, it would be the largest structure in the solar system. It extends beyond the orbit of many of its moons, creating a kind of invisible atmosphere. Particles caught within this bubble form radiation belts and plasma sheets. They flow in loops, bouncing between poles, creating flashes of radio noise that drift through space. The sounds, when translated to audio, are eerie and beautiful. Long howls, chirps, and hisses, as if the planet were whispering across light years. The moons of these planets are not passive observers, they orbit inside or near these magnetospheres, interacting constantly. Io, Jupiter's volcanic moon, spews gases that become ionized and swept into Jupiter's field, creating electric currents that link moon and planet. These currents spark auroras, create radio bursts, and shape the very structure of the field. Europa, Ganymede, and Callisto feel these effects as well, some with oceans under ice that conduct electricity and respond to the magnetic touch. Ganymede, in particular, is remarkable. It is the only moon known to generate its own magnetic field, separate from its planet. This means that within Jupiter's vast field, Ganymede carries a smaller, quieter field of its own, like a single instrument playing within a larger song. When the two fields interact, they create auroral belts and magnetic reconnection events, sudden shifts where lines of force snap and realign, releasing energy. It is a dance of magnetic dialogue, where even moons can sing. These fields are not static. They move. They change. The solar wind, a stream of charged particles from the sun, pushes and compresses them. When solar storms arrive, the fields ripple, stretch, and crack. These disruptions cause changes in the radio emissions, spark brighter auroras, and sometimes eject clouds of particles into interplanetary space. The planets respond with shifts in tone, in rhythm, in frequency. Like drums reacting to a shifting wind, they adjust their song. And still, through it all, the song continues. Voyager recorded the pulses of Saturn and the strange whistles of Uranus. Cassini captured Saturn's radio emissions, eerie with rising tones. Juno listens now, hearing Jupiter's roar and crackle. These sounds are not noise, they are messages. Messages written in charged particles, shaped by invisible forces, carried across the dark. The Song of the Giants is a reminder that power does not always shout, that strength can be silent, invisible, and everywhere at once. The magnetic fields hold the shape of the planet's hearts. They shield, they pulse, they connect, they sing, and we, though far away, are listening. Now we arrive in the quietest part of the giant's song, not where the sound begins, but where it fades into the fabric of space. Here magnetic fields stretch into invisibility, where charged particles drift slowly, and the soft rhythms of planetary motion echo faintly through the void. These fields are not boundaries. They are bridges, between planets and moons, between deep interiors and distant orbits, between past and present. They shape space without touching it, carving out regions where radiation flows, where plasma swirls, where silence is filled with meaning. The song is still there, not as a melody, but as a presence. Something you feel, not with ears, but with understanding. Even now, the song continues to evolve. Jupiter's auroras flicker in real time with the rotation of its deep core, mapping internal currents in the invisible ocean of metallic hydrogen. These auroras brighten not just with the solar wind, but with Io's restless volcanoes. As its sulfur-rich gas flows into space, it is drawn into magnetic lines that twist and funnel toward Jupiter's poles. As the gas crashes into the upper atmosphere, ultraviolet light flares. This constant interaction is like a violin string being plucked again and again, a rhythm tuned to the orbit of a moon, a beat that can be timed by instruments light years away. Saturn, with its mysterious, almost too perfect magnetic field, continues to puzzle scientists. Even after Cassini's final dive into the atmosphere, the mystery of its spin remains unsolved. The magnetic field is so aligned with the planet's axis that it gives no clear rhythm, no beat to count a day by. It's as though the planet sings without pulse, its song not a metronome, but a wind. And yet, Saturn speaks in other ways. When its rings are lit by sunlight, they release particles that enter the field. These tiny additions change the energy, shift the balance. Even frozen rocks, if they drift long enough, become part of the song. Farther out, Uranus and Neptune remain strange and haunting. Their magnetic fields flip and flutter, sweeping through space like lopsided sails. The sun's wind batters them, distorting their fields into shapes we cannot yet fully imagine. Their auroras, when seen, are irregular, blinking on and off like distant candles. These fields might not be steady, but they are honest. They reflect the true strangeness of the worlds beneath them, planets tilted, cold unknown. Their song may not follow any pattern we understand, but it is no less real. It is a reminder that nature does not always seek symmetry. Sometimes it sings in broken rhythms that hold beauty all the same. These magnetic fields also create space weather, storms of radiation that can ripple across entire planetary systems. They can alter the atmosphere, break molecules apart, and even affect spacecraft electronics. When particles accelerate along the field lines, they sometimes hit spacecraft and cause bursts of data, flashes of interference. But from these disruptions we learn, we listen, we discover what cannot be seen, how thick the field is, how fast it turns, how far it reaches. Every glitch is a note, every interruption a clue. And so the magnetic fields not only sing, they teach. They tell us about the interior of planets we cannot see. They reveal the oceans of fluid hydrogen that swirl beneath the clouds. They show us how rotation stirs those oceans into motion, creating electric currents, building invisible armor against the solar wind. These fields tell us that planets are not just shells of gas. They are alive in their own way, pulsing with heat, spinning with weight, pushing energy into space. The song is born deep inside, but it echoes outward in all directions. This energy touches everything nearby. It shapes the behavior of moons, especially those with oceans. It can stir tides under ice, trigger auroras above the poles, even alter the orbits of small magnetically active rocks. The fields connect the entire system. They are not just features, they are networks, lines of force that hold the planet and its family in constant conversation. A moon might orbit in silence, but its ocean may be stirred by a whisper from the magnetic field. A ring particle may spiral inward, guided by that same whisper. All of it, storm, spin, spark, is part of the music. And through all of this, we are the ones learning to listen. Our instruments translate the invisible into colour, into sound, into maps of loops and waves. We take the quiet songs of magnetic fields and turn them into something human ears can understand. In those recordings, we hear more than noise. We hear wonder. We hear planets spinning alone in the dark, surrounded by energy. We hear moons caught in electric embraces. We hear the breath of giants, slow and steady, filling space with a silent hymn. To hear a planet sing is to remember that not all things must be seen to be real. Not all beauty must shine. Some of it hums beneath the surface. Some of it moves through lines we cannot trace with fingers, only with thought. And some of it travels across time, from the birth of a planet to now, never pausing, never ceasing, always turning. And so the song of the giants goes on, through charged particles, through field lines, through auroras and echoes. It moves through Saturn's stillness, through Jupiter's roar, through Neptune's tilt, through Uranus's lopsided twist. It is not a song that ends. It is not a song that waits for applause. It is a song of presence, of persistence, of turning, humming, shining through the dark. We float nearby with our antennas raised and our hearts wide open. We listen, and in the silence between the notes, we begin to understand. Imagine a place where air does not end, where the sky deepens forever into more sky, and where every layer is thicker, stranger, and more distant than the last. On Earth, we think of the atmosphere as something light, a skin of air that fades gently into space. But on the gas giants, on Jupiter, Saturn, Uranus, and Neptune, the atmosphere is not just a cover, it is the planet. These worlds have no solid surface to stand on. If you were to fall into them, you would pass through layers upon layers of gas, each one denser and darker than the one before. You would not land, you would only drift deeper and deeper into pressure, into heat, into mystery. This is what it means to dream in 1,000 atmospheres, to sleep beneath clouds that never stop in worlds without ground, without end, without pause. Each of the gas giants holds its own dream. Jupiter's atmosphere is a swirling gallery of colours, bands of white and beige and rust, torn by storms that span continents, whipped by winds that never rest. The outermost layers are made of ammonia crystals, forming bright ghost-like clouds that stretch across the sky. Below these are darker, water-rich clouds, heavy and brooding, driven by deep thermal currents. Beneath those, the gases grow hot and thick, merging into a strange sea of compressed hydrogen. The pressure rises exponentially. The temperature climbs, but still, there is no floor, no surface, only more atmosphere. As you descend, the light fades. The sun, already dim at this distance, becomes a memory. The weight of the air presses from all sides, not like a blanket, but like the ocean, endless and crushing. But instead of water, you are falling through gas, through molecules that become denser, more packed, more charged. Hydrogen begins to change. Under enough pressure it becomes metallic, not like the metal we know, but a liquid that shines, that conducts electricity, that flows like molten silver. In these metallic depths, Jupiter's magnetic field is born, a powerful, invisible force that loops around the planet and beyond, shaping the space around it. The atmosphere feeds this engine. The deeper you go, the more intense everything becomes. Heat, pressure, speed, and still, there is no bottom. Saturn dreams more softly. Its atmosphere is cooler, calmer, tinged with pastel shades of gold and grey. But it too is layered and deep. The outer clouds are made of ammonia and methane, delicate and slow-moving, shaped by subtle waves and rings of circling winds. Below them, the same transformation occurs. Hydrogen thickens, pressure mounts, and the gases give way to liquids without form. Saturn's atmosphere spins fast. Its days last just over 10 Earth hours, and this speed flattens the planet at its poles, stretching its atmosphere outward at the equator. This gives Saturn its distinct shape, its delicate stripes, and just like Jupiter, Saturn's inner depths hide a metallic core, an engine of magnetism powered by liquid hydrogen. The sky here is not something you rise into, it is something you sink through, endlessly. On Uranus and Neptune, the atmosphere becomes colder and darker. These planets are often called ice giants, not because they are frozen, but because their atmospheres contain more complex molecules, ammonia, methane, and water, mixed in with the hydrogen and helium. These molecules form thick clouds, heavier and more sluggish, layered like blankets beneath a dim and distant sun. The blue of Neptune, deeper and richer than any sky on Earth, comes from methane high in its clouds, absorbing red light and reflecting only blue. Uranus, tilted on its side, rolls through space with seasons that last decades. Its atmosphere holds these long, quiet shifts, absorbing the sun's light in soft pulses, then releasing it again in slow waves of storm. Beneath the blue, the story continues. The atmospheres grow dense, opaque. Storms arise and fade, invisible to us. Winds race around the planet's core faster than sound, trapped in corridors of pressure. Scientists believe these worlds may have icy mantles, slushy layers of water, ammonia, and methane under high pressure, resting between the gas above and the core below. These mantles may flow, they may churn, they may generate the strange, off-center, magnetic fields that twist through space like broken halos. And all of it is atmosphere. To dream in 1,000 atmospheres is to live without boundary. These planets have no hard lines, only transitions. The difference between air and sea is erased. The difference between gas and liquid becomes only a matter of depth. The surface is not a place, it is a pressure, a level, a measurement in atmospheres, where one becomes 10, then 100, then 1,000, and still you are falling. And through it all the planets turn, and this turning is key. Rotation shapes everything, the winds, the storms, the layers of clouds. The rapid spin of the gas giants causes equatorial bulges, jet streams, and vortices. It creates order in chaos, lanes of flow that move in opposite directions. These flows form the bands we see from afar. They look painted, but they are alive, rivers of wind, thousands of kilometers wide, moving at hundreds of kilometers per hour. And between them, turbulence, swirls, ovals, spirals, systems that last for hours, days, or centuries, all of it atmosphere. These atmospheres are not just places, they are processes, they are memory, they are machines of motion, powered by heat from within and shaped by the cold of space. The gas giants release more energy than they receive from the sun. This heat, left over from their formation, rises through the atmosphere, feeding the winds, lifting the clouds, stirring the storms. The planets breathe it out, not in gasps, but in constant exhales that shape everything above. The result is weather without end, currents without shore, a sky that has no ceiling and no floor, and still, it is peaceful. From afar, the gas giants appear serene. Their colours blend softly. Their shapes are smooth. Their storms, even the violent ones, move in silence. There is no thunder here. Only pressure. No lightning to see, only infrared pulses hidden in the dark. But there is beauty in that silence. There is meaning in the weight of a sky that never ends. Let us now follow that endless sky downward, where light grows dim and the boundary between air and matter dissolves into fluid weight. To dream in 1,000 atmospheres is to journey through states of being, each one denser and stranger than the last. The gas giants, massive as they are, do not contain the kind of certainty we are used to. They do not offer firm ground or clear divisions. Instead, they are made of transitions, places where one thing becomes another, slowly, imperceptibly, until what once was gas becomes something thicker, something heavier, something new. And as we fall, the dreams change. They deepen. On Jupiter, the clouds begin high with ammonia ice, delicate and drifting, then deepen into a soup of water vapour and ammonium compounds. Farther down, the pressure crushes the gases into density. At around 1,000 kilometres below the visible clouds, hydrogen becomes something alien. It becomes metallic. Not solid, not quite liquid, but a strange fluid that can conduct electricity like copper. This layer is not surface, it is not even sea, it is movement and compression, churning with deep planetary currents. The atmosphere does not end here. It becomes a different kind of sky, one hidden from sight, known only through equations and gravity. It is in this deep sky that Jupiter's massive magnetic field is born. The planet's rotation, fast and unceasing, twists the metallic hydrogen into motion and motion into magnetism, creating the strongest field of any planet. This field loops out into space, protecting Jupiter and its moons, shaping radiation belts, forming a storm of energy around the entire system. But even deeper lies more mystery. We believe a core exists at the centre of Jupiter, perhaps rocky, perhaps icy, perhaps a thick blend of elements pressed together into something like a shadow of solidity. This core might be 10 times the mass of Earth, wrapped in layers of exotic fluid, cloaked by metallic hydrogen, sealed beneath thousands of kilometres of atmosphere. But no probe has reached it. No light has touched it. It exists in theory, inferred by gravity and motion. And yet its presence shapes everything above. The entire planet swells with its pull. Saturn too holds this dream of endless depth. Its upper atmosphere is colder, softer in colour, less stormy on the surface, but beneath it follows a similar path. Hydrogen becomes liquid, then metallic. Winds churn in bands powered by heat from within. The planet emits more energy than it receives, slowly radiating the warmth of its formation into space. Saturn's core may be less dense than Jupiter's, more diffuse, more mixed, but still it lies hidden beneath miles of spinning sky. The planet's magnetic field, symmetrical and subtle, emerges from these layers, tracing the lines of deep, unseen motion. Saturn may seem gentle from afar, but inside it holds the same roaring silence, the same pressure, the same heat, the same mystery of form. And then there are Uranus and Neptune, where the path through the atmosphere leads to even stranger realms. Their atmospheres begin with hydrogen and helium, but soon mix with heavier molecules, methane, ammonia, water. These ices are not solid in the way we know ice, but compressed into slushes and liquids by pressure we cannot replicate on Earth. The result is a mantle, not made of rock or gas, but something in between, dense and dynamic. These mantles may contain currents of their own, flowing slowly, generating the twisted magnetic fields we observe. Some scientists believe diamonds may form deep inside these planets, carbon squeezed by pressure into solid jewels that fall like rain through layers of methane. Whether true or not, the possibility is enchanting. A storm of diamonds falling through a planet that no one has touched. To descend through these layers is to journey through time. The outer clouds respond to light that takes over an hour to reach them. Deeper down, heat trapped since the planet's formation still presses outward. Deeper still, perhaps, are the leftovers of the dust and ice that formed the planet's core billions of years ago. Each layer remembers something different. The upper atmosphere remembers the sun, the middle layers remember movement. The deepest ones remember formation, chaos, compression, light. And so the gas giants dream in layers. Each layer breathes with a different rhythm. Each one moves to its own pressure, its own wind, its own heat. And yet together they form a whole, a planet without surface, a planet without skinance, a planet where sky becomes sea, where weight becomes temperature, where pressure becomes structure. And in that structure, life may never form, but meaning certainly does. For meaning does not only come from what we know, it comes from what we feel when we imagine. It comes from the knowledge that somewhere in the solar system, 4 great worlds drift in deep sleep, cloaked in cloud and wind and field. Their atmospheres hold no ground, but they hold everything else: motion, memory, power, patience. They breathe without lungs, they change without sound, and they wait endlessly beneath the weight of their own dreaming skies. Let us now settle softly into the deepest part of the dream, the place where atmosphere becomes a memory and pressure becomes the language of a planet's soul. To fall into a gas giant is not to crash or land, but to be folded into layers of endless sky, where time slows, where sound vanishes, where motion continues even when all seems still. In this descent, we lose our sense of where one thing ends and another begins. Cloud blends into vapor, vapor thickens into mist, mist becomes something heavy and warm and ancient. And as we sink, we are not falling away from the planet, but deeper into its presence, deeper into its thought. Because if a gas giant can be said to think, it thinks in pressure, it thinks in storms, it dreams not in images, but in movement, columns of gas rising and falling, waves of wind sliding past each other, currents beneath the clouds curling in silence. These movements are slow and deep and powerful. They do not rush, they do not stop. They flow continuously, shaped by gravity and rotation, and the heat that pulses up from the core. This is the dreaming of the atmosphere, unconscious, immense, and steady. The energy that feeds these dreams comes from long ago. When the gas giants formed, they gathered immense amounts of matter: hydrogen, helium, dust, ice. The collapse of this matter created friction, and friction created heat. Some of that heat was lost to space, but much of it stayed, trapped beneath thick blankets of atmosphere. That heat still rises now, billions of years later, driving winds, lifting clouds, shaping storms. It is not new energy, it is memory turned into motion. The planets are still breathing the warmth of their own birth, and the dreams continue. Jupiter's bands of wind racing in opposite directions are not just weather. They are records of deep atmospheric waves, of stability built from imbalance. Saturn's delicate rings may lie above its atmosphere, but their existence changes the sky below. Shadows fall, light reflects. Ice particles influence the upper clouds. Even the presence of a thin ring system shapes the atmosphere's uppermost flow. The dream is wide. It includes not just depth, but height, not just gravity, but light. Uranus and Neptune carry quieter dreams. Their distance from the sun makes them cold, yes, but not still. Their atmospheres are layered in mystery. Storms appear suddenly, flicker across the blue, and vanish again. These are not storms like ours, bound to ground and cloud. These are deep atmospheric motions born in internal layers, breaking through into view like thoughts rising into wakefulness. Neptune's great dark spot, for instance, is a vortex that rises from the depths and travels across the sky, shrinking, changing, disappearing. It is a short dream compared to Jupiter's long one, but no less meaningful. The farther we go, the less we see. The pressure increases, the temperature climbs, the molecules crowd so tightly they begin to act like one. At some point, there is no more atmosphere as we know it. There is only state, a region of fluid hydrogen compressed into something not quite liquid, not quite gas. Somewhere in these depths lies the metallic layer, where hydrogen becomes something truly strange, dense, flowing, brilliant. This layer generates magnetic fields so large and strong they carve space around the planet. These fields are not surface features, they are signs of depth, of internal dreaming turned outward. And deeper still, perhaps, is a core, not a surface, not a place to land, but a centre, a region of heavier elements fused together under pressure beyond imagination. No one knows exactly what it is like. Some say it may be rocky, others say it may be liquid. Still others believe it may have dissolved into the metallic hydrogen above it, becoming part of the atmosphere itself. Whatever the truth, the core is not alone. It is surrounded by thousands of kilometers of atmosphere, all pressing inward, all holding the memory of formation. The dreams of 1,000 atmospheres are not loud. They do not call out to be heard. They do not rise quickly or fade suddenly. They linger. They unfold. They repeat. A storm on Jupiter may last centuries. A wind on Neptune may blow without rest for millennia. These are dreams that care nothing for days or years. Their time is measured in revolutions, in thermal pulses, in shifts of layer upon layer. They are the dreams of planets that do not wake. And yet, from the outside, we can listen. We can watch. Spacecraft like Voyager, Galileo, Cassini and Juno have sent back glimpses of clouds curling in new patterns, of storms forming with no warning, of winds rising from nothing and returning to silence. Instruments have felt changes in gravity, in magnetism, in heat. Each measurement is a word in the language of these dreams. And though we have only begun to understand, we know enough to be humbled. Because the gas giants remind us that not all worlds are meant to be walked upon. Some are meant to be wondered about. Some are not destinations, but meditations, on size, on time, on form. They exist not as places, but as processes. To observe them is to feel the vastness of what we do not know. To imagine falling through their skies is to lose all sense of edge or boundary. To drift forever through shifting weight, colour, and soundless motion. In these dreams there is no centre and no end. Only depth. Only motion. Only breath. And that is enough. That is everything.